G'day again. This video is on what I call as the SUVAT formula. So SUVAT. Gee, that U looks like a V. It looks almost identical. The SUVAT formula. Other people call them the equations of motion, that sort of thing. And what they are as follows. So we've got V equals U plus AT. We've got S equals UT plus half AT squared. We've got V squared minus U squared equals 2AS, and finally S equals half U plus VT. They're the four formulas that we can use for any situation, as long, and I'll put a big asterisk here, must have constant acceleration. Okay, it's not variable acceleration, constant acceleration. In other words, A equals 10 or A equals negative 3.2 or something like that. Not A equals 2 times its velocity, or A equals 2 times the t plus 6v or something like that. Constant. So yes, you can use it. Yes, you can use it. No, you may not. No, you may not. Okay, so that we can only use that for constant acceleration. And so let's just crack straight into an example and have a look at what we do. So what we're doing is we're looking at all the four formulas and looking at which one should we use. They all use different variables. I didn't explain what they were. I better do that. But and we're looking at writing down what we know and what we're trying to find out. So U is your initial velocity. V equals your final velocity. T, of course, is time. S is your displacement. Okay, and what I've forgotten, A is acceleration, of course. Okay, so they're all your what we're doing, and this connects together. Anything that has rectilinear motion will follow these laws, and they make it really easy to solve. So let's do this. We'll do an example up above. As soon as I've sort of delete this, sorry, I'm just going to get rid of this. And we'll do an example. Alright, and here we go. So, a body is moving at constant acceleration, starting at 5 meters per second and ending at 11 meters per second after 3 seconds. Find its acceleration and find the distance travelled. Okay, really simple question. Let's have a look at it. The first thing I would do in any of these questions is write down what you know. Okay, so it's moving at constant acceleration, so we can use the SUVAT formulas. It starts moving at 5 meters per second, so its initial velocity is equal to 5. At the end, the final velocity is equal to 11 meters per second, and the time that it takes to do this is 3 seconds. What we want to find for this first question is the acceleration, so A equals question mark. So you need to look at your four formulas and decide which one uses U, V, T, and A. And the answer is the first one, and your formula is V equals U plus AT. And if we just do a quick rearrangement of these, A will be equal to V minus U over T. V minus U, yeah, that's right. Equals, velocity is 11 minus its initial velocity, which is 5, over the time taken, which is 3. So that's 11 minus 5, 6 over 3, so that's 2 meters per second squared for our thing. So that's the acceleration, 2 meters per second squared. Beauty, that's part A done. Distance travelled. So we've got the same situation here, but let's just write it all down again just in case. Initial velocity was 5, final velocity is 11, time is equal to 3. Now we know our acceleration is equal to 2, so what we want to find is the distance travelled in that time since it started. It's displacement. And so now we can use any of the formulas, because all we need is four pieces of information to be able to use the formulas, and we've actually got 5 here, so it's happy days. So just to use a different one, I'll do S equals UT plus half AT squared. So that's equal to UT, so 5 times 3 plus half. A is 2. T squared will be 3 squared. So that's equal to 15 plus 3 squared. 9 times 2 is 8. Well, they just cancel out, so it's plus 9. That's equal to 24. This is in meters, so it's travelled 24 meters in that time. And there we go. So nice and easy. Write down what you know, write down what you want to know, and use the appropriate formula that will get you into that. Let's just do one more. Let's just go Mr. Heaton is sliding along a table with uniform acceleration. That's fun, isn't it? Uniform acceleration, and his initial velocity is 8 meters per second. Find his acceleration if he comes to a stop after 5 meters. Okay, so I'm sliding along a table, sliding along a table, and I've got uniform acceleration. My initial velocity was 8 meters per second, but what's happening is I'm obviously slowing down because I come to a stop and I stop moving after 5 meters there. So that's 5 meters where I come to a stop, and what we want to know is to find my acceleration. Okay, so can I do a redo? Hope so. Oh, you're kidding me. Oh, thank the Lord. Okay. Oh, I thought I'd lost it. That would be annoying to rewrite. So, what do we know? My initial velocity is equal to 8. Final velocity? Well, because I come to a stop, my final velocity is 0. That's what I'll be at the end. Okay. I travel 5 meters, so my displacement is 5 meters. And do I know anything else? No. Initial velocity, acceleration. We don't know anything to do with time, but what we're trying to find is acceleration. So A equals what? Now, which formula connects together U, V, S, and A? So U, V, S, and A. What we want is the third, which is V squared minus U squared equals 2AS. And we want to solve this for A. So therefore, A is equal to a V squared minus U squared over 2S, just rearranging, equals V squared, so that's 0, minus U squared minus 8 squared over 2 times 5, so that's equal to negative 64 over 10 equals negative 6.4. And that's we had meters per second, so that's all in meters per second. Now, so there's your acceleration. It's a negative acceleration. It starts at 8 meters per second, but it slows down, finally comes to a halt. Mr. Heaton stops at that point. Just another point before I leave you is that make sure everything's in common units. Meters per second here. We've got 5 meters here. If they were in different units, just be really careful to change those. Any time or acceleration or everything must be in the same units. Be really, really careful. And that's it. Enjoy.